Okay, this video is going to be based on BMAPhysics 2I. So let's just get that out there. Okay, so that was a very short video of a ball being thrown up from a balcony. So the ball is being thrown up from the balcony, and we're going to give you a little bit of different information. X, T, V, I, V, F, A. And now we're going to assume, the assumption we're going to make is we're going to assume that the book is right, and the acceleration due to gravity is negative 9.81 meters per second squared. Now, we have to know some things, and what we know is for the total flight, when I do it, my total flight is 52 frames times 1 second is 30 frames. So I'm going to know that my time is going to be 52 divided by 30 is going to be 1.73 seconds. Time is 1.73 seconds. Now, we're going to know something about this. X. Now, in my previous one that I did, my X was negative 4.1 meters. And what I'm going to say in this one, my X is also negative 4.1 meters. And now you guys are going to jump, or should jump right all over that, and you should say, no. It can't be negative 4.1 meters. This distance here is 4.1 meters. So I understand when the ball just dropped straight down, it dropped 4.1 meters. But that's not what happened here. What happened here is the ball went up and then it came down. So if this distance is 4.1 meters, well, it must have gone further than 4.1 meters. So this X has got to be much greater. It can't be the same. But it is. Because what we're really thinking about is that there's two moments in time. The two moments in time is when is the ball at this level, and then the second moment in time is when is the ball at this level. And what we want to know, what we want to plug in for here is not the path that the ball took. We don't care what path the ball took. What we want to know is we want to know how far apart is its beginning and its end. The path in the middle does not matter. We care about the beginning and the end. Now, somewhere we have to account for the fact that it went this extra distance, and that extra distance is accounted for in our time. When he just dropped the ball, it took 0.9 seconds. When he threw the ball up and down, it took up and then it fell back down, it was 1.73 seconds. So that's how we can account for that. So now we want to solve for VI, and that's going to be another little wrinkle because VI is no longer 0, so that's going to take a little bit of mathematical doing. So figure out what equation we're going to use, and I'm going to jump right to it. It's going to be this one. X equals VIT plus 1/2 AT squared. Okay, so now we're going to have X is negative 4.1 meters. My VI I do not know. My T is 1.73 seconds plus 1/2 negative 9.81 meters per second squared. And then my time is 1.73 seconds squared. Okay. Now, I'm going to go ahead and I'm going to show you how to do this all out on your calculator. What I'm going to do is I'm going to start with this negative 4.1. So negative, clear that, negative 4.1. Now I'm going to subtract off 1/2, which I'm going to say is just 0.5, times negative 9.81 times 1.73, and remember, we're going to square it. And I'm going to get 10.58. And now what I'm going to do is I'm going to take 10.58 and I'm going to divide it by 1.73, and I'm going to get 6.1 meters per second. So VI is 6.1 meters per second. And what I used on my calculator was a really good feature on these calculators, and that's this key right here, this ANS. If I want to take 6.115707.803 and multiply that by something, I don't know what I want to multiply it by. I want to multiply it by 3. All I can do is if I do second ANS, now it holds that previous value in memory, and then I can multiply it by 3, and there I've got it multiplied by 3. Now also, if I make a mistake in an earlier calculation, this one up here, suppose I want to bring that back, I can do second enter, and then if I keep doing second enter, that will eventually pop up, and then I can go back and I can edit it if I want. So if I want to make that a positive, I can I can just delete that out. So I can edit. I don't really have enough time to talk about that right now, but we'll get into that more as we go along. Okay. Well, what I'd like to do in the next 2 minutes is I would want to know if I throw a ball up. I'm going to do a new problem here. If I throw a ball up with an initial speed of 6.1 meters per second, how much time will it take to reach the top of its flight? Well, at the top of its flight, its final velocity is going to be 0 meters per second, and we always know for free fall that our acceleration is negative 9.81 meters per second squared. And so I want to use A equals VF minus VI divided by T. I'm going to rearrange that, so I'm going to get T equals VF minus VI over A. I'm going to get T is equal to 0 meters per second minus 6.1 meters per second. All that divided by negative 9.81 meters per second squared. And so the time, so this time here, the time to go from here to there, I'm going to calculate to be 6.1 divided by 9.81, 0.62 seconds. 0.62 seconds. Now if I multiply that by my frame rate, 30 frames per 1 second, I get 18.6 frames, or about approximately 19 frames. And when I analyze that video, what I find is that the ball goes up for 19 frames before it starts coming back down. That's that video.